Hello, my name is Larilyn Maligdong and today we will discuss data analysis. Analysis of data. This text will not attempt to teach readers how to conduct a statistical analysis, rather, it will indicate the kinds of things that statistical analysis can and cannot do. The Dictionary of Statistics and Methodology is an excellent resource for non-technical definitions of statistical and methodological terms used in the social and behavioral fields. Role of statistics. The purpose of statistical analysis is to summarize observations or data in such a manner that they provide answers to the hypotheses or research questions. The field of statistics involves methods for describing and analyzing data and for making decisions or inferences about phenomena represented by the data. Cautions in using statistics. The nature of the data to a large extent determines the statistical techniques that can be used legitimately. Certain techniques are appropriate for use with categorical data, others with ordinal data, and so on. Second, the more controlled the research setting, the less is the need, in general, for certain statistical techniques. Steps involved in statistical analysis. Regardless of the specific techniques or tests employed, there are certain basic steps common to virtually all statistical analyses. Those steps will be discussed briefly before taking a more detailed look at the major types of analysis. The establishment of categories. In order to organize and analyze the data collected for a study, it is necessary to place them in categories. The identification or establishment of categories should take place before the data are gathered. The actual categorization of the data takes place during or after the collection process. In establishing categories, 4 basic rules or guidelines should be followed. 1. The set of categories or values, i.e., the classification scheme, for any one variable should be derived from a single classificatory principle, which is determined by the research question or hypothesis being investigated. For example, if one were studying the relationship between size of the reference collection and reference performance, 2 sets of categories would be needed. 2. Each set of categories should be exhaustive. That is, it should be possible to place every observation in one of the categories of the set. This does not preclude the use of a miscellaneous or catch-all category, such as other. 3. The categories within each set should be mutually exclusive. This means that it should not be possible to place a specific observation correctly in more than one category. 4. Last, but not least, the development of categories should be based on a sound knowledge of the subject matter and an anticipation of likely responses. A person establishing categories for reference questions should have had enough reference experience and have done enough reading about the topic to be able to predict the types of questions that will appear in a study and establish categories accordingly. Coding the data. Once the categories have been established and data assigned to them, it is necessary to convert the new data or responses to numerical codes. These codes are, in turn, assigned to specified locations in data files, particularly if computer data analysis is planned. Analyzing the data, descriptive statistics. Graphs are especially useful for displaying the findings of a research study that has a large number of cases. Statistical analysis can indicate how many people, objects, scores, or whatever achieved each value or fell into each for each variable that was measured. These calculations, known as frequency distributions, are usually reported in tables. Analyzing the data, inferential statistics. Inferential statistics are used to make inferences about what exists on the basis of only partial evidence. They are most commonly used to predict or estimate population parameters or characteristics based on random sample statistics. They can also test hypotheses using tests of statistical significance to determine if observed differences between groups or variables are real or merely due to chance. Parametric statistics. Parametric statistics require the assumption of a normal population or distribution, but can almost always be relaxed. A normal population is not required, as the sampling distribution of sample means is likely to be normal. Some examples of frequently used parametric tests include the following. 1. Z-test. The Z-test determines whether a group's results are significantly different from those that would be expected due to chance alone. It could be used to determine whether a book's physical condition is representative of the entire library collection in general. 2. Students' t-test, a test that can be used in place of the z-test where there is still only one group but where, in contrast to the z-test, the standard deviation of the population is not known. 3. Difference of means, a commonly used statistical test which utilizes the t-statistic and which determines if the statistical difference between the mean scores of two groups is significant. 4. Analysis of variance, a statistical test which represents an extension of the difference of means test. It utilizes the f-statistic, and it tests for differences among the means of more than two samples or groups. 5. Post hoc tests. These test the statistical significance of differences between group means that have an overall difference calculated after an ANOVA or a regression analysis (RA) has been done. 6. Reliability coefficient, a statistic that indicates the reliability of measurement, i.e., a test, scale, etc. They range from 0, completely unreliable when observed variance is attributed to random error. 7. Pearson's product moment correlation coefficient. This test generally is referred to as simply the correlation coefficient. It measures the degree of linear association between two variables or the extent to which changes in one value correspond with changes in another value. 8. Regression, a type of analysis that, as is the case for correlation, can be used for descriptive and inferential purposes. In the former case, Pearson's correlation coefficient is used as the basis for developing a simple linear regression equation to predict the value of one variable when the value of the other variable is known. Non-parametric statistics. Non-parametric statistics are less powerful than the parametric tests and require larger samples in order to yield the same level of significance. They do not require the assumption of a normal population and, therefore, are often used with smaller samples. A significance level of 0.05 means that there is a 5% probability that the researcher will reject a hypothesis that is actually true. 5 common examples are as follows. 1. Chi-square test, X2. This test is useful for determining if a statistically significant relationship exists between two categorical variables. 2. Mann-Whitney U-test. This is one non-parametric equivalent of the difference of means test, and is used to test for a significant difference between two groups. 3. Wilcoxon sign test. This test can be used instead of the Mann-Whitney when the data are not symmetric. 4. Spearman rank order correlation, or Spearman's rho. This is a non-parametric correlation coefficient that can be calculated for ranked or ordinal level data. 5. Kroskal-Wallis test, a non-parametric alternative to analysis of variance. It is appropriate when one has a number of independent random samples and an ordinal scale level of measurement. Selecting the appropriate statistical test. The various statistical tests must meet certain conditions before being appropriate for use. Certain tests call for a normal population, others for a particular level of measurement. Most of the examples presented here were intended for the analysis of either one group or two groups. There are also statistical tests intended for more than two variables. Consider an experiment to test the effect of bibliographic instruction, BI, on the library skills of university students. Cautions in testing the hypothesis. In using statistics to test hypotheses, One must always keep in mind that inferences are based on probability, and one can never rely on statistical evidence alone for a judgment of whether a hypothesis is true. A single statistical acceptance of a hypothesis does not prove it to be true with absolute certainty. One simply decides, based on the statistical results, that a hypothesis should not be rejected. Meta-analysis can blur the distinctions between studies and provide misleading conclusions, according to articles by Trahan, Lopez-Lee, and Chow. Statistical analysis software. With the use of online questionnaires, the data can be transported into statistical software programs as soon as the respondents submit the completed survey. Probably the most popular statistical package is IBM's SPSS, Statistical R package for the social sciences. Using a statistical software package via servers is an efficient technique for analyzing large amounts of data. IBM SPSS Statistics 18, formerly PASW Statistics Base 18, is a powerful statistical analysis program for the PC with built-in support for Python scripting. Analysis of non-quantified data. Not all research data is susceptible to quantification, and such data may not lend themselves to statistical analysis. The analysis of qualitative data differs from that of quantitative data in nature and in the nature of the process. One of the key activities of qualitative analysis is the coding of data. Summary. The typical basic steps in statistical analysis are categorizing the data, coding the data, and calculating the appropriate statistics. Descriptive statistics deal with tabulating data, their presentation in tabular, graphical, or pictorial form, and the calculation of measures. Inferential statistics are used for making inductive generalizations about populations based on sample data and for testing hypotheses. Both types of statistics permit interpreting quantitative data in a way that the reliability of conclusions based on the data may be evaluated objectively.